Hello everyone, this is Dr. Yuzo. Today we are going to start our Module 3, Superposition. So here are the learning outcomes, and first we're gonna talk about the motivation, why we would like to consider to use this technique. Second, what is it? Third, how to conduct. Well, the detailed procedure is gonna be presented in the specific examples. Here we just talk about some very important tips. Last, but not least, as you know, examples. We're gonna go over some examples to see how we need to really do it. All right, let's start now. First, what is so-called superposition for? Before we talk about this motivation, so by reviewing the scan chart, we can easily tell the superposition is one of the so-called additional circuit analysis techniques, which is based on the previous KCL, KVL, Ohm's law. Please keep it in your mind that the nodal and the mesh analysis are always sufficiently solve any circuit. We have said this several times before. Module 2 is the most important module, and superposition is just one technique you could consider to use. So what can we use it for? So superposition is providing ability to reduce a complicated problem or say circuit to several easier circuits. And in each one of those easier circuit, we can only have one single independent source. Here we are talking about independent source, not dependent source. Okay. Second, what this technique is. It is saying in any linear circuit, if it contains multiple independent sources, the current or voltage at any point in this circuit, or say network, may be calculated as the algebraic sum of individual contributions of each independent source acting alone. So how to conduct this? Some tips here. First, when we are determining the contribution due to an individual independent source, any remaining independent sources are made zero. So how to make independent source zero? And we need to recall the knowledge we learned from Module 1 regarding short circuit and open circuit. So how to make a voltage source become zero? Literally, we want to make this voltage source output 0 volt. And how to make this happen? Short circuit, right? If you recall the concept of short circuit, we know the short circuit cannot tell us any information about current. However, it guarantees a 0 voltage cross. On the other hand, open circuit can guarantee a 0 current goes through. Therefore, if we try to make a current independent source 0, we are making it open circuit. The next tip about how. Never touch dependent sources. Okay, they are untouchable. In other words, we are looking for the contribution due to an individual independent source. However, dependent sources are always there. You can't make them 0. Next, you need to be careful. This technique, superposition, could only be applied on linear circuits. What does it mean by linear circuit? It means the circuit parameters like resistance, inductance, and capacitance, they do not change the value with different applied sources. Ideally, if you think resistance, inductance, and capacitance, their values never change, no matter how much voltage or how much current you apply on. So these are called linear elements. Therefore, the circuits are called linear circuits. And obviously, we also need to have a rough idea of what it means by nonlinear elements and thus the nonlinear circuit. There are some examples like transistors, diode, and very simple switch. If possible, I'm probably going to learn them more in future. But now, this ECE 235 guarantee you that everything is linear. So we're going to go ahead to look at the examples to learn how to really apply this technique to analyze the circuits.